All right, in this video, we're going to learn some things. I maybe not learn anything new for you. It's a very easy section. Most of these things students already know, but I'll go ahead and do some examples and definitions nonetheless. So suppose I have the numbers 2, 7, 23, 13, and 4. If I want to add up all those numbers, I can use a shorthand. So a shorthand for the sum of those numbers is, and this is where I use a Greek symbol. That's the Greek symbol sigma. So if you see a sigma followed by an x, that means that you're going to add up the given numbers. And then you just add them up like normal. That's all it is. It's a shorthand. This would add up to be 49. Then if I want to find the average of those numbers, is we would write it with an x with a bar over it, and that would equal sigma x divided by n, where n is the number of items that we have. So we would do 2 plus 7 plus 23 plus 13 plus 4, and divide it by how many numbers do we have? We have a total of 1, 2, 3, 4, 5 numbers. So I would divide the total by 5. And so 49 over 5 would be the answer. And you can leave it like that. There's no reason to change it. But if you feel like changing it to a decimal, it is equal to 9.8. So this leads us to the first definition. The mean of n numbers is x bar equals sigma x over n, where n, of course, is the total number of numbers. We also call another term for this is the average. So either one of those words will be fine for this course. Find the mean of -3, 0, 28, 5, 0, -10, and 17. First, we make note that there's 1, 2, 3, 4, 5, 6, 7 numbers. So my lowercase n is equal to 7. And then let's add up sigma x. So we have -3 plus 0 plus 28 plus 5 plus 0 plus -10 plus 17. Let's see, this equals 25, 30, 20. It looks like 37. And so the mean of those numbers, x bar, will equal sigma of x over n. So that's 37 divided by 7. And once again, you can leave the numbers like that if you want. If you want to get a decimal, that's usually going to be all right too. And let's see what we have. So if I do 37 divided by 7. For this section, I'm going to use 3 decimal places of accuracy. So that's going to be 5.286. Now when I circle my answers like this, I'm indicating to you that either answer is acceptable. In a class with 4 exams, Hector scored 81, 79, 87 on the first 3 exams. What does he need on the 4th exam to average an A for the course? An A, of course, will be 90%. So he needs to average a 90 out of 100. So we need his average to equal a 90. So the formula for his average is the sigma of x over n. That's supposed to equal 90. My sigma of x, I covered up my scores. I have 81 plus 79 plus 87. And then the last test, I don't know, so I'm going to put an X in there since that's what I'm trying to figure out. This will be a total of 4 scores, and that will equal a 90. Now what I'm going to do is multiply both sides by 4. So I'll have 81 plus 79 plus 87 plus X is equal to 360. Let me add up these 3 numbers here. So that looks like 160, 247. And then if I subtract 247 from both sides, I see that he needs a 113 on the last test. That means that, unfortunately, Hector cannot get an A. All right, so Hector decides to settle on a B. Let's ask a new question. What does Hector need on his 4th exam to get a B? So he's decided to set his sights a little bit lower. So this time he wants his average test grade to equal an 80, or better, of course. And so let's put in our numbers. I got my sigma of x over n equals 80. My sigma of x, we had 81 plus 79 plus 87 plus x over 4 equals 320. Actually, I'm going one step ahead of where I should have been. That equals 80. Now I'll go ahead and multiply by 4. And I get 81 plus 79 plus 87 plus x equals 320. I'll add those numbers up. We get 247 plus x equals 320. I'll subtract the 247 from both sides. And it looks like x is equal to 73. So Hector needs a 73. He needs a 73 or better. If you have n numbers ordered from smallest to largest, the median of those n numbers it's given by the following formula. There's two possibilities here, so I'm going to split it up into two pieces. So if n is odd, we're going to pick the middle number. So that's when n is odd. Otherwise, we pick the mean of the middle two numbers. That's when n is even. So as an example, the median of 1, 2, 3 is median equals 2. I'm picking the middle number since there's an odd number of numbers that I have to deal with. On the other hand, the median of 0, 1, 2, 3 is, this time I have an even number of numbers, so I take the mean of the middle two. Where are the middle two? 1 and 2. Notice that these examples, I already have the numbers arranged from smallest to largest. So I'm going to take the mean of the numbers 1 and 2. So I'll take 1 plus 2 divided by 2, and I get 3 halves, or if you prefer, 1.5. Next, compute the median for the numbers. Here we have negative 12, negative 8, negative 3, pi, 17, 29, 47. So now how big of a set of numbers do we have? We have a total of 1, 2, 3, 4, 5, 6, 7, 8 numbers. N equals 8, and that is even. So I look for the middle two numbers. Notice that it's already been organized from smallest to largest. So what are my middle two numbers? Well, those are numbers 4 and 5. So 1, 2, 3, 4. So 4 and 5, those are my numbers 4 and 5. Fourth and fifth numbers. So then my median will be the average of those two numbers. So I'll take negative 3 plus pi and divide by 2. If you want the decimal for it, it's approximately 0.071. So unless I specify otherwise, either of these answers would have been fine. The mode of a collection of numbers is the number or numbers that occur most frequently. If each number only occurs once, we have no mode. Determine the mode for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, since each number only occurs once, there's no mode. Another example, determine the mode for 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one's easy. The mode equals 2 since that occurs more than any other number. Determine the mode for, this time we'll have 1, then I'll have 2, 2, 2, then I'll have 3, 3, 4, 5, 6, 6, 7, 7, 7, 8, 9, 9, and 10. Now we have more than one mode. If you look, the 2s occur most often, 3 times, and the 7s also occur most often, also 3 times. So we simply write mode equals 2, 7. Determine the mode for 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and this pattern continues all the way until we get to 10 tens. Well, this solution is also easy. Since there are 10 tens, that number 10 occurred more than any others. So the mode is simply 10. The midrange of a collection of numbers is the mean of the smallest and largest of those numbers. As an example, the mid-range of the numbers 1, 2, 3, 4, all the way up to 97, 98, 99 is that's going to be the sum of the mean of the smallest and the largest. So I'll take the 1 plus 99 and divide it by 2, and that equals 50. The mid-range of 1, 2, 3, ... all the way until we get to 100, so this time I'm going up to 100, is mid-range equals 1 plus 100 over 2. So that's 101 over 2, or if you prefer, 50.5. The last topic that I want to talk about is something called percentiles. And so suppose you have a collection of numbers arranged from smallest to largest. K over 100 times n if you are looking for the kth percentile. So we take a look at this thing here, K over 100 times n. So this can equal some things. This equals either a decimal or a whole number. So if K over 100 times n is a decimal, round up to the next number in the list. If K over 100 times n is a whole number, .5. As an example, compute the 90th percentile of 1, 2, 3, ... 98, 99, 100. So I need to compute the 90th percentile of the numbers, the whole numbers from 1 to 100. So for the solution to that, let's take a look. We want to do 90 divided by 100 and multiply it by the total number of numbers. So that's 90. Now, since it ends in a whole number, we do this right here. Since it ends in a whole number, we add 0.5. So we have 90 plus 0.5 equals 90.5. If we do a similar example, compute the 90th percentile of 1, 2, 3, ... 8, 9, 10. So here, now we just have 10 numbers. First thing we should do is take 90 divided by 100 and multiply it by 10. And that will equal 9. And since it's a whole number, we add 0.5 to it. So 9 plus 0.5 equals 9.5. Example, compute the 25th, 50th, and 75th percentiles of 10, 11, 12, 14, 15, 15, 16, 17, 19, 20, 21, 22, 25, and 28. Let me see how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so we have n equals 14. And now let's take a look at 25th percentile. So if we start with that one, we're going to take 0.25 times 14 and find out it equals 3.5. So what do we do if we end up in a decimal? We round up to the next whole number. So I want position number 4, and let's take a look at number 4 in the list. 10 is number 1, 11 is number 2, 12 is number 3, and 14 is number 4. So Q1 equals 14. That's called quartile 1. It has a special name. So that 4 indicates that you want item number 4 on the list. Now, for the 50th percentile, what do we do in this case? Here we're going to take 50% times 14 will equal 7. 7 is a whole number. So let me see. 1, 2, 3, 4, 5, 6, 7. Since it's a whole number, we want to add 0.5. So we take our 16, which is in position 7, and add 0.5 to it. So that is Q sub 2, which is the 50th percentile, or quartile number 2. And then finally for the 75th percentile, which as you might have guessed is quartile number 3. First I need to do 75% times 14, and that will equal 10.5. So we ended up in a decimal, so I'm looking at position number 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it looks like our Q3 equals 21.